Hello students, last time we have discussed the structural isomerism. What are isomers? What is meant by isomerism? And types of isomerism in coordination compound. We have discussed there are two types of isomerism shown by coordination compounds. First one is structural isomerism and second one is stereoisomerism. In structural isomerism, there are 7 types. Out of that 7 types, we have discussed ionization isomerism, hydrate isomerism, ligand isomerism, and the lecture is concluded with linkage isomerism. Let us continue the remaining 3 types of structural isomerism, that are coordination isomerism, coordination position isomerism, and polymerization isomerism. And later on we are going to discuss what is meant by stereoisomerism. So coordination isomerism. In this isomerism there is interchange of ligands in the complex cation and complex anion. At that time, that isomerism is called as coordination isomerism. What is the meaning of this? That means certain ligand is acts or present in a complex cation and same ligand is present in a complex anion. Got it? So let us see with the help of example. So see CONH36, this is the complex cation, and CrCN6, this is the complex anion, and its isomer is CrNH36 and COCN6. How this shows coordination isomerism? See here, this is the first isomer. In case of this complex cation, to this cobalt, 6 ammonia molecules are coordinated. Ammonia molecules are neutral. On cobalt there is positive charge and therefore this is complex cation. While this is anion, complex anion. How? To this chromium, 6 cyanide ions are coordinated. So more number of anions are coordinated to chromium, therefore on this square bracket there is negative charge. It is complex anion. See its isomer. In case of this, what happened to this chromium, neutral ammonia molecules are coordinated and therefore on this square bracket there is positive charge. Therefore this is complex cation. That means in this case chromium is the part of complex cation, while in case of first isomer it is the part of anion. Say cobalt is now coordinated with 6 cyanide ions. In first isomer it is coordinated to 6 ammonia molecules. Here as it is coordinated to 6 cyanide ions, on this square bracket there is negative charge. That means cobalt is the part of anion. Followed? That means this isomerism is due to interchange of ligands between complex cation and complex anion. So here there is exchange of ammonia as well as exchange of cyanide. Followed? So such isomerism is called as coordination isomerism. Let us see second example. CONH36 Cr, this is oxalate molecule. Cr is coordinated to oxalate. This is anion. Again this is cation. Cobalt is the part of cation. Chromium is the part of anion. See its isomer. Now chromium is attached to ammonia. There is interchange of ligand, ammonia and oxalate ion. Now to chromium, ammonia molecules are coordinated, while in case of this, to this cobalt, oxalate ions are coordinated. That means first one, this is cation, and cobalt complex, this is anion. So in this way there is interchange of ligand. One more example, CuNH342 plus That means this is cation. To the copper, ammonia molecules are coordinated. But in this case, what happened? To the copper, 4 chloride ions are attached, coordinated. Therefore, here there is a negative charge. In case of this, there is positive charge. This is cation, this is anion. Similarly, to the platinum, 4 chloride ions are attached. Therefore, there is -2 charge. This is anion. But see, in case of this isomer, platinum is coordinated to ammonia. 4 ammonia molecules, neutral molecule. Therefore, on square bracket there is positive charge. Platinum is the part of cation. So, in this way, here platinum is the part of cation. Here it is part of anion. In this way, here there is an interchange of ligand between complex cation and complex anion. This is called as coordination isomerism. Sometimes same atom is acts as coordination center in both cation and anion. Let us explain with the help of this example. Now see, here chromium. To this chromium, 6 ammonia molecules are attached. Therefore, this is cation. In second square bracket, chromium is coordinated with 6 thiocyanate ion. Therefore, it is the part of anion. Followed? But see its isomer. In case of this, chromium is attached to 4 ammonia molecules, okay, and 2 thiocyanate ions. While here, in case of this second square bracket, to this chromium, 2 ammonia molecules and 4 thiocyanate ions are coordinated. See, in case of this, there are 6 ammonia molecules. In this isomer also, there are 4 ammonia as well as these 6 ammonia molecules. Here 6 thiocyanate ions are attached to chromium. Here also these 2 and these 4 ions, thiocyanate ions, are coordinated to chromium. Got it? So that means same atom, chromium, is acts as coordination center in both cation and anion. Got it? So this is called as coordination isomerism. Then see next one, type of structural isomerism we are discussing. This is coordination position isomerism. This is the special type of coordination isomerism in which what happened? There is different placement of ligands, and generally this isomerism is shown by bridged complexes. Again I repeat, in this isomerism there is different placement of ligands and it is shown by bridged complexes. So position of ligand is changed and therefore coordination position isomerism is the name of this type of isomerism. Let us explain with the help of example. See here, in case of this isomer, there are 2 cobalt ions, central metal ion, 2 hydroxyl ions, they are acts as bridged atom. Followed. But see the coordination of ammonia molecules. Here in case of this isomer, 4 ammonia molecules are attached to first cobalt ion, while here 2 ammonia molecules are attached to second cobalt ion. Along with this, 2 chloride ions are attached to cobalt, but to this cobalt no chloride ions are attached. Followed. Total number of ammonia molecules are 6. Total number of chloride ions are 2. Okay. See its isomer. Here again 2 cobalt ions are present. No doubt 2 cobalt ions. 2 hydroxyl ions are acts as bridging atom. Okay. No problem. But see here. Here now to this cobalt ion 3 ammonia molecules and 1 chloride ion is attached. On this side also 3 chloride ion and 1 chloride ion is attached to the cobalt. That means here 6 ammonia molecules are equally distributed. 2 chloride ions are also equally distributed. Followed, and therefore this isomer is called as symmetrical isomer. While above isomer is called as unsymmetrical because the distribution of ammonia and chloride ion is not symmetrical, is not same Here 4 ammonia molecules are attached. 2 are attached to this cobalt. To this cobalt no chloride ion is attached, while all 2 chloride ions are attached to cobalt. Therefore it is called an unsymmetrical isomer. So this unsymmetrical and symmetrical isomers are due to different placement of ligands, and this isomerism is shown only by bridge complexes. Then see last type of structural isomerism, that is polymerization isomerism. What is this? The compounds which having the same empirical formula but different molecular formula, that compound shows this type of isomerism. Molecular compositions are multiples of the simplest stoichiometric arrangement. How? See here. This is the first isomer. CONH3 thrice, NO2 thrice. That means 1 cobalt ion, 3 ammonia molecules and 3 NO2 ions are attached. Therefore, N is equal to 1. Let us see isomer number 2, in which N is equal to, that means number of atoms or ions, it is doubled. It is twice. See now in this isomer 2 cobalt ions are present. Okay. And ammonia molecules are present 6. In first isomer they are 3. Here there are 6. So they are doubled. Similarly NO2 ions, here they are 3. In case of this they are 6. Follow? So this is the isomer which is called as polymerization isomerism. See here, or it may be written as cobalt. See, here there is 1 ion, here there is second ion. So total number of cobalt ions are 2. Total number of ammonia molecules are 4, and these 2, it becomes 6. NO2 2, NO2 4, it becomes again 6. So in case of this isomer, the value of N is equal to 2. Then say N is equal to 3. That means cobalt in first isomer 1, in third isomer it is 3. Here there are 3 ammonia molecules. In this third isomer it becomes 3 into 3, 9. Here NO2, they are 3 in number. Again they becomes 9 in number. How they are 9? Let us see. Cobalt, first see cobalt. Cobalt 1, cobalt 2. These are 2 in number, therefore cobalt 3. 2 cobalt, 1 cobalt, it becomes 3. NH3, 5 in number. And see, these are 2 into 2, that means 4. So 4 and 5, 9. N is equal to 3. Here NO2 is 1, but NO2 are 4. 4 into 2, 8. 8 and 1, it becomes 9. So in this way, it is multiples of stoichiometric arrangement, and therefore such isomerism is called as polymerization isomerism. When N is equal to 4, that isomers are written here. Cobalt are 4 in number, cobalt 1, and these are 3. See here 3. 3 cobalt 3 and 1, it becomes 4. NH3 is 6 in number. Okay. So 3 into 4, it becomes 12. So 6. So these are 2. 2 into 3, 6. Okay. 6 and 6, it becomes 12. Similarly, NO2 4. 4 into 3, 12. In this way, here the number of metal ion as well as ligand, it is multiple in next isomer. Such type of isomerism is called as polymerization isomerism. So this is about structural isomerism. Now let us see next type of isomerism, stereoisomerism. Up till we have discussed what is meant by isomer, what is meant by isomerism, types of isomerism, structural isomerism and stereoisomerism. In structural isomerism, we have discussed in detail 7 types of structural isomerism: ionization isomerism, hydrate isomerism, ligand isomerism, linkage isomerism, polymerization isomerism, coordination isomerism, coordination position isomerism. Now see second type, stereoisomerism, which is also called as space isomerism. Here see, in case of this isomerism, what happened to the same metal atom or ion, same ligands are attached. Okay, there are two molecules, or we can say two compounds, in which same metal is present, same ligands are present, but in space their arrangement is different. Such type of isomers are called as stereoisomers, and the phenomenon is called as stereoisomerism. Let us see in detail the definition. The same ligands, when coordinated to the same metal ion in two different compounds, and the arrangement of the ligand in space is different, then the two compounds are said to be stereoisomers of each other, and the phenomenon is called as stereoisomerism. Followed. So the ligands attached to metal atom or ion, there is formation of complex, but in space the arrangement around metal ion of ligand is different. Let us see types of stereoisomerism. There are mainly two types of stereoisomerism: geometrical or CIS-TRANS, or it is also called as position isomerism. Generally, it is called as geometrical or CIS-TRANS isomerism. Second type of stereoisomerism is optical or dextro-levorotatory isomerism. Let us see first type, geometrical isomerism. What is geometrical isomerism? It is the name indicates that this isomerism is due to different geometrical arrangement of ligands around central metal ion or atom. Okay, then that isomers are called as geometrical isomers, and the phenomenon is called as geometrical isomerism. So this isomerism is due to the difference in the geometrical arrangement of coordinated groups about the central metal atom or ion is known as geometrical isomerism. This is also known as CIS-TRANS isomerism. We have already discussed. So geometrical isomerism is also called as CIS-TRANS isomerism. What is cis isomer? When same type of ligands are on the same side of the metal, or same two ligands occupy adjacent position to each other, then the isomers are called as cis isomer. Followed. So same ligands are present on same side of metal atom or ion. What is trans isomer? It is opposite to cis. When same ligand are on the opposite side of the metal, then the isomers are called as trans isomer. So in case of this, what happened? That same ligands, same type of ligands are opposite to that of metal. They are placed oppositely on the side of metal. Remember well, this isomerism is not possible with the compound having coordination number 2, 3 and tetrahedral complexes with coordination number 4. In case of complexes having coordination number 2, we can't judge which two positions are same, which two positions are opposite to each other. Therefore, it is not possible for these complexes to show such type of isomerism. Similarly, it is not possible for coordination number 3 compounds as well as tetrahedral complexes with coordination number 4. We are not able to identify which is cis, which is trans, because in case of tetrahedral complexes, all 4 positions are adjacent, they are equivalent to each other, no 2 positions are opposite to each other. So this is the reason why tetrahedral complexes do not show geometrical isomerism. But this isomerism is shown by 4 coordinate square planar complexes as well as 6 coordinate octahedral complexes. So in detail we have to discuss geometrical isomerism in square planar complexes. Of course, coordination number is 4, that means 4 ligands are attached to central metal atom or ion. Similarly, it is shown by octahedral complexes in which coordination number is 6, that means 6 ligands are attached to the central metal atom or ion. Let us start. First, geometrical, or it is also called as cis or trans isomerism in square planar complexes. In these types, there are various types. Let us see type number A, Ma2B2. Of course, M is central metal ion, to which A and B monodentate ligands are attached. Monodentate means the ligand which donate only one electron pair to metal ion, okay, and coordinate to the metal ion or atom, and there is formation of coordinate bond. Let us see with the help of this example. Dichlorodimine platinum. Okay, so this is the example of this type, Ma2B2. See, this is the structure. This is called as a cisplatin. Okay, in case of this structure, we observe that this is central metal ion. Structure is square planar. To one side of square planar, see here at these 2 positions there are 2 ammonia molecules. That means these 2 same ligand are present on same side of metal ion, that is platinum. Followed, similarly, these chloride ions, same ligands, they are present on same side of central metal ion, that is platinum. Therefore, this is called as cis-platinum. Cisplatin. Followed? Then see second structure. In this structure, we observe that this is central metal ion platinum. 2 same groups, 2 same ligand, they are present opposite to each other. Similarly here, they are present, chloride ions, they are present opposite to each other. Therefore, this is called as trans isomer, and hence the name of this isomer is transplatin. Followed? So, 2 same ligands are present on same side, that is cis isomer. They are present opposite to each other. It is called as trans isomer. Next type. See second type, B type, Ma2BC type. Again, M is central metal ion. B and C are monodentate ligand. The ligand donates only one electron pair to the metal ion and forms coordinate bond. Example, to this platinum, 2 ammonia molecules, 1 chloride, 1 bromide ion is attached. Okay, see this is the structure. Now see in case of this structure, to this platinum, 2 ammonia molecules as well as 1 chloride, 1 bromide ion is attached. We observe that 2 same ligands, 2 ammonia molecules are present on same side of this platinum. Okay, now see this is chloride, bromide, they are present on second side of the platinum, but here 2 same ligands are present on same side of platinum. Therefore, this is cis isomer. See in case of this, same ligands NH3, they are opposite to each other. Okay, bromide and chloride, they are opposite to each other. Therefore, this is called as trans isomer. Ammonia molecules, same ligand, these are present opposite to each other. Next one, C type. This is MABCD type. M is central metal ion. A, B, C, D are the monodentate ligands. All donates only one electron pair to central metal ion, forms coordinate bond and form coordination compound. See, this is the example platinum. To this platinum, one ammonia, one chloride, one bromide, one pyridine is attached. Now the question is that how to identify cis isomer and trans isomer. Here platinum is attached to chloride, pyridine, NH3 and bromide. We say in this structure to this pyridine ammonia is cis. Okay, to this pyridine ammonia is cis. But in this structure what happens? See, this ammonia is opposite to that of pyridine. Therefore, this is called as trans isomer. This is called as cis isomer. Okay, we have to fix one position and now change the group or ligand on this position. Now in next isomer, instead of pyridine, now consider chloride. We say that chloride is cis to ammonia. When chloride is present here, we say that chloride is trans to ammonia. In this way, in this category, 15 isomers are possible. Okay, so friends, today we conclude here this lecture. In next lecture, we continue this isomerism. Thank you.